right, so we have just a little bit more to talk about as far as exponential growth and decay goes. There's actually two more formulas that we're going to do, but I will tell you that these two formulas are just decay problems. Speaking of decaying, maybe my little document cam is decaying, right? Because it doesn't seem to want to focus. Hopefully it'll come back in focus here pretty soon. But we're basically going to be talking about money that you are putting into a bank, okay? And what's really neat when you're in a bank, or what banks do, I should say, is that they give you interest, right? If you put your money in the bank and you leave it there, they're going to give you more money. That's how they get your business and how they make money, okay? I know it seems a little counterintuitive, but I promise that it is. And then what ends up happening is that they're making more money off of you than you're making off of them. But what happens is that they are going to take some money. You're going to take some money. You're going to put it in the bank. And then they're going to run a program, and they're going to add in interest, okay? So at the end of 1 year, okay, they're going to run a program. They're going to add some interest to it. And then you now have just a little bit more money than you started with. Again, this is putting the money in the bank and leaving it there, okay? Sometimes what they do is that they'll take your money, and about halfway through the year, they'll run their program. And so they'll add interest here. And then at the end of the year, they run the program again. Okay, and so then you end up with a little bit more money than you had before, okay? What this is called it's called compounding, okay? So it's called a compound interest. If they're going to compound the interest or run their little math program, their little computer system, okay, if they run it once a year, so just once, then the formula that you use is exactly the same as the formula you used before, right? You take your principal amount, you add the rate, and you multiply it. You raise it to the t power, right, in terms of how many years it's going to stay inside the bank, okay? Now keep in mind, this particular formula also had the minus sign because of decay. I promise the bank, if you leave your money in there, it's not going to take money away from you for leaving your money there. They're going to take money away from you for other things, but not for that, okay? If they compound it in the middle of the year, it's called a semi-annual compounding, okay? Or it might be called a biannual. And if that's the case, then they've compounded your interest twice in 1 year, okay? And so that's a different formula. It's not this formula anymore. It's a different formula. Sometimes they might compound your interest what is called quarterly. So that means they're going to do it 4 times a year. So they might compound run their program here and add some interest. Then run it again halfway through, and then halfway through run it again, and you get more and more money. You're going to get a little bit more each time, okay? So that's quarterly. If they're going to do it, maybe they run it at the end of January, the end of February, the end of March, the end of April, right? That's monthly, okay? Again, these are all different formulas. Let me show you what that formula is, okay? That formula is very similar to this one, but you take your principal amount, okay? Again, we're only going to be adding, right? Because again, it's not going to take it away, so we're just adding. But here's what you do. You take their rate, whatever the rate is that they're going to give you, you're going to divide it by the number of times they're going to compound that interest during the year, okay? And then you're going to raise it to the n times t. Okay, let me tell you what everything stands for. Again, A is the same. It's the amount that you end up with at the end. Excuse me. P is the principal amount. That's the amount that you start with. R is still the rate, but what changes is N. So N is the number of times it gets compounded. By the way, this is my abbreviation for for compound, but the number of times it gets compounded a year. Okay, so if it is semi-annual or biannual, n is going to be 2 because it gets compounded twice in the year. So that rate gets divided by the 2, right? But then because it's just, happening twice in that year, if it's in there for 1 year, then it gets compounded twice. If it's in there for 2 years, it's going to be 4 times. If it's in there for 3 years, it's going to be compounded 6 times. Do you see how that kind of works? If it's quarterly, then n equals 4. If it's monthly, n equals 12. If it's weekly, n would equal my favorite number, 52. Okay? If it's daily, n would be 365. Okay? There's one other type of interest that gets compounded, and that is when the computer program doesn't just run once and done, once and done, once and done, right? This happens when it's semi-annual or it's quarterly or it's monthly. It gets run and then it's done. It gives you an amount and then it gets run and it's done. Sometimes the computer program will run continuously, meaning it is continually adding more and more money, okay? More and more money. That is called a compound continuously. Okay, it's when that happens continuously. The program is just constantly adding and adding and adding money. Now, it's not like it's adding a lot of money. It's adding like pennies, right? We're talking like fractions of pennies, okay? But that formula is going to be close to the same. So A, remember, is the amount. P is the principal, the amount that you start with. But this time, you're going to do E. Do you remember what E was? E was 2.71, okay? You're going to do E to the R times T, okay? So it's the initial amount, then you're going to do the base of E, and you're going to raise it to the RT. This is when it's compounded continuously. Let's go try some examples so you see what I'm talking about. All right, so this is from your workbook, okay? So let's go in and take a look at lesson 8.3. This is page 125 of your workbook, okay? We're going to do a couple of these problems together. Look at you getting free stuff, okay? All right, so for question number 1, the directions say we're going to write the equation and then find the value, okay? So we're going to write an equation for the amount of money you're going to have after an $800 investment. It's going to earn 3% annual interest compounded yearly, and it's going to happen for 4 years, okay? All right, so here we go. $800 investment. So we're going to do A equals, my initial amount is 800. Then I'm going to do 1 plus, right, because we're adding in that money. It's a 3% annual interest, which as a decimal is 0.03, okay? And it says that it's compounded yearly for 4 years. So technically, n is 1, okay? And so when we go to do that formula where n is 1, you don't have to do this part. Because remember, the rate divided by 1 is still the rate. And so that's going to be the same as this. Remember that 1 times t is going to be the same as t. So we're just going to do this formula right here. So it's going to be 1 plus the 0.03, and we're going to raise it for 4 years, so to the 4th power. Okay, and now it's just a matter of plugging it in. 800, 1.03 to the 4th power gives us 900.4. Now listen, I stopped writing for a reason. You need this to make sense, right? So remember when we talked about the deer problem, we don't need body parts laying around or anything, right? So you need to have this in terms of dollars and cents. So this would be 41 cents. So $900, 41 cents. Okay? All right, let's do the next one. Number 2. We have an $1,100 investment. So that's our principal amount. Okay, so here's P. It's going to earn 0.9% annual interest. Remember, as a decimal, that's going to look like this, okay? The annual interest is compounded monthly. That means my N is going to be 12 because there are 12 months in a year. And then, of course, it's happening for 6 years. So this would be the formula with the 1 plus R over N. Okay? It's definitely handy to have these formulas nearby. Okay? All right, so here we go. 1100, A equals, all right, 1 plus, now remember, we're going to do our rate divided by N, which is 12. And then that's going to be N times T, or 12 times 6, which is 72. So over 6 years, this is going to be compounded. They're going to run their program a total of 12 times each year, so total of that 72 times the whole time it's there. All right, so 1100. 1 plus, I'm going to do 0.009 divided by 12, and that is to the 72nd power. So that's going to give us a total of $1,161.01 if we round to the nearest penny. Okay. When you go to do number 3, semi-annually, N is going to be 2. This particular one, number 4, it says the annual interest compounded continuously. You're going to use the formula that has the E in it. Okay. All right, let's talk about number 5. The directions for number 5 say to find the amount that would be needed to invest. So you're finding for this one the initial amount every time. So P is what you don't know. Okay. All right, so here we go. We're going to do, our goal is 700. That's the amount we want at the end. P, I don't know, so I'm going to put a P. This is 3.5% annual interest compounded yearly. So I'm going to do 1 plus 0.035. And this is happening for 3 years, so to the 3rd power. Okay? So what you're going to do is you're going to go figure this out. What is 1 plus 0.035 to the 3rd power? Right? So 1.035 to the 3rd power is that number. And then you're going to take 700 and you're going to divide by that number. Now listen, the more digits that you round, the farther away your answer is going to be. And so it really, really helps, especially if you're using a scientific calculator, that you let the calculator do the math for you. So you have some options. I'm actually going to show you a little trick. The calculator is going to store this last answer in. So if you use the answer button down here at the bottom, notice how it's blue. So you hit the blue button, right, with my blue Band-Aid. Okay. So the calculator is going to do that for you and go type that in. Another neat little trick that you can do. So let's say I want to do 700 divided by, and I know it's this number way up here. You can use the arrows, scroll up, highlight it, hit enter. I'm going to do 700 divided by that big old honkin' number and hit enter. Okay, let me show you what happens if you round. So if you did 700 divided by 1.1, you're $5 off. That is kind of a big difference. So you definitely want to make sure that you're using that big decimal. Okay. All right, question numbers 9, 10, 11, and 12. You're going to use Desmos for. So let me show you how these work. So again, it says you're using a graphing calculator, but we want our investment to grow to 2,000. So for number 9, we want 2,000 to be our answer. My initial amount is 1,500. It says that it is a 2.5% annual interest compounded yearly, so I'm going to do 1 plus 0.025. And it's being raised to the x power. So what you're going to do on Desmos is you're going to go type into Desmos this on one side. Then you're going to go type in on the other side or into another equation, y equals, make sure you do a y equals 2,000, okay? And then see where those two intersect, where they meet, and you'll get your answer. That's going to tell you how many years it's going to take to go from 1,500 to 2,000. Make sure you send me an email if you have any questions.